Second formula from this chapter, section formula. When we are going to use this section formula, first we write the statement of this section formula. If P in bracket x comma y divides the line segment AB in which A is equal to x1 comma y1 and B is equal to x2 comma y2 in the ratio m1 as to m2. In some book it is given as m as to n, in some book it is given as m1 as to m2. Then coordinates of point P are, that is x coordinate, the value of x coordinate is m1 x2 plus m2 x1 upon m plus n. How we get the x coordinate of that point P? We divide the line segment AB having coordinates of point A are x1 y1 and coordinates of point B are x2 y2 in the ratio m as to n, internal division. Then x is equal to m1 x2 plus m2 x1 upon m plus n, and y coordinate of that point P is going to be calculated by this formula m1 y2 plus m2 y1 upon m1 plus m2. In 12th standard m and n ratio is given. Here in textbook m1 m2 is given. X is equal to m1 x2 plus m2 x1 upon m1 plus m2, and y is equal to m1 y2 plus m2 y1 upon m1 m2, m1 plus m2. That we have to prove. For that we consider coordinate axis. Horizontal is x, vertical is y. A point x1 y1, B point x2 y2, P point x comma y. We divide in the ratio m1 as to m2. From point A we draw perpendicular A, P, B on x-axis, that are A are perpendicular on x-axis, P is perpendicular on x-axis. Similarly, BT is perpendicular on x-axis. Now from point A we draw one parallel line, that is AQ, and another parallel line from point P, that is PC. What we have to find? Again I will repeat that statement of section formula. A and B, these are the 2 points having coordinates x1 y1 and x2 y2. If we join the 2 points, then we get one line segment, and the name of that line segment is segment AB. Now point P, divide that line segment AB in the ratio m1 as to m2. Internally in the ratio m1 as to m2. Then the coordinates of point P we have to find. First we consider the coordinates of point P are x comma y. Here we have to find the value of x and value of y. That value is x is equal to m1 x2 plus m2 x1 upon m1 plus m2, and y is equal to, y coordinate of that point P is equal to m1 y2 plus m2 y1 upon m1 plus m2. For that we consider the 2 points A and B, x1 y1 and x2 y2. Point P, divide AB segment internally in the ratio m1 as to m2. Then from point A, P and B we draw 3 perpendiculars on x-axis, and from point A and point P we draw the 2 parallel lines to the x-axis. Here first we consider, let point P in bracket x comma y. Proof of that theorem. Let P in bracket x comma y divides the line segment AB in the ratio M1S2 M2 means AP upon PB we get as M1 upon M2. AP upon PB is equal to M1 upon M2 because we already considered that point P divides segment AB in the ratio M1S to M2. Now we find some values. First we find the value of AR. Here we consider that AQ is parallel to RS. Therefore, suppose here angle S is 90, therefore Q is also 90. Similarly, S is also 90. This line is parallel to this line, therefore these two angles are corresponding angles. Therefore, by angle criteria, we can prove these two triangles are similar. Here, triangle PAQ is similar to triangle BPC. By which criteria? Angle criteria. By angle criteria, we are going to succeed to prove these two triangles are similar. Now, if the two triangles are similar, then sides are in proportion. Therefore, ratio of first side PA upon BP equal to ratio of second side AQ and PC, and ratio of third side topiwala PQ and BC by CSEST, or corresponding sides of similar triangle or sides are in proportion. Now we know the value of PA and BP. PA upon BP is M1 upon M2. We have to find all these values. AQ. From figure we find AQ. AQ is similar to RS. AQ is equal to RS. The coordinates of this point are x1, 0. Why we consider the 0 as a x coordinate? Y coordinate? Because the point R lies on the x axis, and all the points which are lying on the x axis must have y coordinate 0. Here x, 0, and here x2, 0. The coordinates of point O. AQ is equal to RS. RS is equal to OS minus OR. OS minus OR. OS means x and OR means x1. Therefore, we get the value of AQ as x minus x1. Now we find the value of PC. PC is equal to ST. How we can calculate ST? ST means OT. Consider O as reference point. OT minus OS. OT minus OS. What is OT? OT is the distance x2 and OS distance is x. Similarly, we find PQ. Now I want to find the PQ. PQ can be written as PL minus PQ. PS minus PQ. PQ can be find out as PS minus QS. PS minus QS. PS and QS means AR. QS means AR. The value of PS is Y and value of AR is Y1. Y minus Y1. Y minus Y1. Now we find BC. BC is equal to BT minus CT. BT minus CT. But CT means what? CT means PS. Then we get BT. Y2 minus Y. Y2 minus Y. PS value we calculate. Y2 minus Y. Substitute all these values in equation 1. Suppose we consider this as equation 1. Putting these values in equation 1, we get PA upon PB is M1 upon M2 equal to AQ is x minus x1 and PC is x2 minus x. Cross multiply M1 x2 minus x is equal to m2 x minus x1 multiply m1 x2 minus m1 x m2 x minus m2 x1 m1 x2 plus m2 x1. We shift that negative terms towards left side, this negative term towards right side. Then m1 x plus m2 x. m1 x2 plus m2 x1 equal to, take x common, we get m1 plus m2 in bracket. After taking x common, now shift that m1 plus m2 towards left side. m1 x2 plus m2 x1 upon m1 plus m2, that is the value of x coordinate. X coordinate of that point P is m1 x2 plus m2 x1 upon m1 plus m2. And similarly, by putting PQ and the values of PQ and BC in this equation, after simplifying we will get the value of y as m1 y2 plus m2 y1 upon m1 plus m2. This is called as section formula.